The following service information is brought to you by the Alco Controls Division of Emerson Electric. An evaporator in a refrigeration system is like any other kind of reservoir. It needs a steady supply of liquid that changes flow depending on load. Controlling that flow is the job of the expansion valve. The heat load is the starting point in the design of every refrigeration system. The size of the load sizes the system and each component that will go into it. Sizing components is not new to the technician or designer. He knows each component must be capable of doing its individual job in a system. All components, including expansion valves, have a rating which tells the user what to expect in performance and under what conditions he can expect that performance. These values of expected performance are called nominal ratings, and it's important to understand the limitations of using such ratings. A wire, for example, nominally rated at 20 amps, may or may not be capable of operating at 20 amps. The nominal rating only says that it will carry 20 amps under certain rated conditions. Fortunately for most components, the conditions in the real world are very close to those used in their rating. For many other components, such as compressors and expansion valves, things are a little more complicated. Their performance depends very much on the conditions under which they operate. For expansion valves in particular, the size selection must go beyond nominal ratings. The service technician or designer must look at all factors that will affect the true capacity of his valve selection. There is a price for doing otherwise. One might assume that as long as a TEV is big enough, it can't miss doing the job. A TEV that is too big is like a hammer that is too big. It may be too big to respond to small system requirements. It could overfeed the coil and send dangerous liquid down the suction line and onto the compressor. Compressors can't pump liquid. A lost compressor is an expensive price to pay for an oversized expansion valve. There's a better way, but it's not to use an undersized valve. The evaporator depends on the TEV to deliver enough refrigerant for it to do its job. If even with the valve wide open, there isn't enough flow to keep the evaporator supplied, the system will lose capacity, and the installer may see a lost customer. A few minutes spent looking at all factors in a proper valve selection will save time, money, and customers. One of the primary purposes of a TEV is to meter refrigerant to an evaporator coil. Since all flow must pass through the valve, the flow characteristics of the valve is critical. It is this flow that determines the valve's capacity. The measure of a valve's capacity depends on two things: the quantity of liquid a valve can physically pass and the operating characteristics of the refrigerant itself. The actual size of a TEV is only a part of its ability to pass enough refrigerant to allow the evaporator to do its job. Were there not a pressure difference across the valve, there would be no flow through the valve. The higher the pressure difference, the greater the rate of flow. It's important to note that it is the pressure difference at the valve that determines flow. It is not, as is commonly thought, the difference between discharge and suction pressure measured at the compressor. All pressures in a refrigeration system are a combination of the refrigerant pressure, the pressures generated by the compressor, and the pressure drops that occur in the piping and components carrying the refrigerant. All of these factors must be accounted for in determining the actual pressure difference at the TEV. That pressure difference will have a lot to say about how much capacity a valve will have. The greater the pressure difference, the greater the capacity of the valve. A graph of a nominal 2-ton valve shows that with a high enough pressure difference, the valve can exceed 3.5 tons. This valve would be too large for a 2-ton installation with a pressure difference this high. The valve would probably hunt and end up flooding the evaporator. In selecting a valve to give proper flow rate, the pressure difference across the valve must be estimated and used. How much refrigerant a TEV can pass will be a determining factor in system capacity. As we will see, capacity is not only dependent on flow rate, it is also dependent on the operating conditions of the refrigerant itself. Valve capacity will vary dramatically based on 3 factors of the refrigerant's condition. The first is the type of refrigerant used. The second is the temperature of the liquid entering the valve. And the third is the saturation temperature of the evaporator. Simply stated, the valve itself does not care what refrigerant type is being used in the system. While in practice, the valve's power element will be matched to a particular refrigerant type, the valve's purpose is to meter liquid refrigerant regardless of type. But in metering a given quantity of liquid to an evaporator, the resulting heat removed will be quite different depending on the refrigerant. As an example, while R502 and R22 have very similar pressure temperature curves, their heat removal characteristics are quite different. Operating under similar evaporator temperatures of 5 degrees Fahrenheit, 1 pound of R502 will absorb almost 69 BTUs of heat, while 1 pound of R22 will absorb a little over 93 BTUs. It is this difference in heat absorption that will give a TEV a different capacity depending on the refrigerant used. As is the case with refrigerant type, a TEV can pass a given quantity of liquid but provide lower capacity because the inlet liquid temperature is too high. As a general rule, as liquid temperature goes up, capacity goes down. Valve capacity can vary as much as 20% from nominal as inlet temperature varies from rated conditions. More on rating conditions in a few minutes. The important point is that the extra heat that is in a high temperature inlet liquid must first be removed upon entering the evaporator. That heat removal is inefficient and robs the system of capacity. For maximum capacity, the liquid line temperature should be as low as possible. The capacity that a TEV finally has will depend on the temperature of the evaporator it is feeding. The amount of refrigerant that a coil must have to maintain a specific design temperature is directly related to that temperature. As evaporator design temperature goes up, the capacity of a TEV also goes up. This means that in low temp applications, a larger valve is needed to provide the same capacity. On the other hand, this same valve would be too large for the same tonnage system operating at air conditioning temperatures. It is clear that with variations in valve sizes, pressure drops across the valve, refrigerant, liquid line temperature, and evaporator saturation temperature, there is no such thing as a 3-ton expansion valve. A valve carrying that rating only has that rating at a certain set of rating conditions. Where ratings appear, the rating conditions must be taken into account. For the purpose of rating expansion valves, an industry-wide standard set of rating conditions has been agreed upon. For R22 and R502, the inlet liquid temperature is to be 100 degrees. The evaporator saturation temperature is 40 degrees, and the pressure drop across the valve is 100 pounds per square inch. For R12, all rating conditions are the same, except pressure drop, which is reduced to 60 psi. It is only under these conditions that a TEV can be called a valve with a specific capacity. Under any other conditions, that same valve will have a different capacity. To select a valve that will properly match system load, the user must choose from the full extended capacity chart. The extended chart will give the precise capacity for any valve under all possible operating conditions. By first selecting based on refrigerant, then evaporator saturation temperature, then pressure drop, the user can quickly find the valve that will most closely match his particular system. Where liquid line temperature is different from the rating temperature of 100 degrees, the user may need to modify his selection after adjusting for the difference. Selecting a valve with all factors taken into account will provide maximum capacity at a minimum cost. And that's enough to keep any customer.